Hello, and welcome to Allison's World of Englo. If you are watching this right now, you are either in one of my practice areas or my lab area. Today, we will be discussing the gate exhibit. Over here is the gate. You click on this red button here to change the gate's view and gate type. For example, if you want to see this from the perspective of language in using a NOT gate, you click on the buttons corresponding to those types, and it will display in language type a true and false sentence. In this case, the false sentence is cows are pigs. You can alternate the input and output of this gate by clicking on the arrows. As you can see here, the input is the arrow pointing to the gate, and I can change it from this false sentence of cows are pigs to the true sentence, the sky is blue, by clicking on the arrow. And I can keep alternating that to change my input. I can change the output of the gate by clicking on it as well. The output is the arrow pointing away from the gate. So I click on it to change it to the true sentence, the sky is blue. What we're doing here is testing our understanding of different logic gates, and we can confirm that we are correct with our statement by clicking on the gate itself. In this case, the true sentence of the sky is blue would be flipped to the opposite of it, in this case a false sentence, cows are pigs. And clicking on the gate itself confirms that and gives us the prize of a cookie. Cookies can be used throughout the exhibit to get out of different traps and move on throughout the different lab exhibits. If we were incorrect, it would show a giant red X. So for example, if I made this the same, it will show me my giant red X here. The purpose of the logic gate, after all, is to test your understanding of different logic operations. To do so, you input different inputs and outputs based on your chosen gate. So if you wanted to double check that you were correct with your understanding of the AND gate, for example, you can double check that for an input of 1 and 1, that you will get the output 1 by inputting into the gate those inputs and outputs. So the input of 1 and 1 with the output of the 1 by setting the input arrows that point to the gate to 1 and setting the output arrow that points away from the gate to 1, and double check that by clicking on the gate itself, and it will display a green check mark if that is correct. If you set it, however, to an incorrect answer, such as 1 and 1 giving you a 0, then when you click on the gate, it will display a red X. As you input different combinations of input arrows and output arrows, and check the gate will give you different kinds of hints. In this case, since we keep getting it wrong, the gate is telling us the definition of an AND gate, which is an AND gate's output is 1 when all of its inputs are 1. Otherwise, it is 0. In this case, we have different inputs and setting it as an output of 1, which does not work in this case, which is why I keep getting it wrong. And it will keep doing so and giving you different kinds of hints and telling you things, like in this case, it's telling me not only the definition of the gate, but that my input in this case is 0 and 0, and asking me what my output should be. The gate itself will keep interacting with you and giving these types of hints until you finally get it right. And then it'll show you the green check mark and then automatically reset. You have a choice of seeing these inputs and outputs from several different points of view. You can see it from the electricity, numbers, true/false, language, and pure language view. The electricity view will display the input as low voltage and high voltage, and clicking on those arrows will change that. The numbers view will display the input as zeros and ones when you click on the input arrows and output arrows. The true/false view will display the input and output as true and false, those exact words themselves, just as the language and pure language view will display true and false sentences such as cows are pigs and fire is hot to indicate true and false with the gate. Finally, you can pick the type of gates that you would like to work with by clicking on the red button and picking either the NOT gate, the NOR gate, the AND gate, the XOR gate, the OR gate, the XNOR gate, and the NAND gate. All of the gates have 2 input arrows except for the NOT gate, which only has 1 input arrow. I hope that you enjoy working with these puzzles and increasing your understanding of logic operations and other engineering concepts. Thank you again.